Hello everyone. In this lecture, we'll go through practically how to segment an image using Watershed algorithm. And we'll do it in OpenCV using Python. So basically, segmentation means dividing a particular image into a number of clusters. Clusters means in the case of image, it will be a segment. So in this lecture, we will discuss the theoretical concept part also. And also I will show you how to implement the code using Python in OpenCV. Right? So let's start the class. So this is in OpenCV using Python, and I am Dr. Dibyajyoti Bora. So today's topic is image segmentation with Watershed algorithm in OpenCV using Python. Okay. A simple concept is that a grayscale image, we can view it as a topographic surface where high intensity denotes peaks. I hope you all are aware with the basic concept of intensity, right? So when high intensity is there, it denotes peaks and hills, while low intensity denotes valleys. You start feeling every isolated valleys, they are local minima. Okay, remember, those two terms are there, na? Maxima and minima. So valleys here, the concept is valleys is the local minima with different colored water, that is levels. As the water rises, depending on the peaks, the gradients nearby, water from different valleys, obviously with different colors, will start to merge. To avoid that, you build barriers in the locations where water merges. And you continue the work of filling water and building barriers until all the peaks are under water. Then the barriers you created gives you the segmentation results. And this is the philosophy behind the watershed algorithm. Right. Now, here in this approach means when we do the watershed segmentation, you can find my research work in the internet. Obviously, different papers are there. You just type watershed segmentation by Dr. Dibyajyoti Bora, then you will get a lot of papers where I discuss the basic concepts of watershed segmentation and the pros and cons of this. The con here is the over segmentation. And this over segmentation occurs due to noise or any other irregularities in the image. So OpenCV implemented a marker-based watershed algorithm where we specify which are the all value points to be merged and which are not. So we specifically actually denote those points which to be merged, which to not to be merged. It is an interactive image segmentation. That is the main benefit of this watershed segmentation. Okay. Now, what we do is to keep different levels for our object we know and label the region which we are sure of being the foreground or object with one color, label the region which we are sure of being background or non-object with another color. You got it now, foreground and background. We will keep the foreground those with some color, okay, that we want as important object, and those who in the background as non-object with a different color. Finally, the region which we are not sure of anything, label it with 0. Means those things we are not sure either it is important or not important. We are in between them. We don't know about that. Then we will put or we'll label with 0. This is the concept of marker. Got it? So then we apply the watershed algorithm and our marker will be updated with the labels we gave. Then the boundaries of the object will have a value of -1. So you got it, the philosophy of watershed and how that philosophy is applied in the watershed segmentation algorithm. But to reduce the over segmentation, and which occurs due to the noises present in the image, we take the help of marker-based watershed algorithm. So we basically mark those things which we consider as important object in the foreground, and those which we consider as non-object in the background, And those which we are confusing about, we are confused that whether they are important or not important, we mark them with 0. So basically marker-based concept is clear to you. Now let's come to the coding part. We are considering one image with coins, very popular image that we usually take as a sample image for segmentation, right? In this image, the coins are touching each other. Even if you threshold it, it will be touching each other. Threshold, you know, na? Threshold, with the help of thresholding also, we get segmentation. Little bit of segmentation we got about from that also. But here, due to the problem, that problem is what? The coins are touching each other, will not get the proper result. See, for thresholding, we are using this code from matplotlib, import pyplot as plt, image we did the image. This in the previous lecture, I told you how to set the path where exactly the image is located, how to read that image, and how to display it. Same thing here I am doing here. Then first we read the image. Okay, suppose this image is not found, then this message will be printed. And now we convert it into gray image. With this cb.color BGR to gray. Then we threshold it. cb.threshold function, gray 0 to 55. You know the values, right? 0 to 55. Then cb trace binary nb plus cb.trace auto, because this thresholding algorithm is the autosus thresholding algorithm. So we got the result like this. But now we need to remove any small white noises in the image. For that, we use morphological opening. To remove any small holes in the object, we can use morphological closing. So got it? So morphological opening to remove any small white noises and any small holes, we remove it using morphological closing. Right. Now we know for sure that the region near to the center of objects are foreground and the region much away from the object are background. So only reason we are not sure is the boundary region of the coins. Now we need to extract the area which we are sure that they are coins. Erosion removes the boundary pixels. So whatever the remaining, we can be sure that it is coin. Now that would work if objects were not touching each other. But now in this case, in this particular image, what happened? The coins are touching each other. So what happened that another option is there to find the distance transform and apply a proper threshold. So we need to find the area which we are sure that they are not coins. For that, we dilate the result. You got it? What we are doing why we are doing the dilation? Okay, so dilation will increase the object boundary to background. This way, we make sure that whatever the region is in background in result is basically a background, and this since boundary region is removed. See the image. In this case, here you can see that when white region shows your foreground and black region shows your background. Now, remaining regions are those which we don't have any idea, whether it is coins or it is the background. Now, for that, watershed algorithm will be used. Means watershed algorithm should find it. These areas are normally around the boundaries of coins where foreground and background meet. Foreground and background meet. Or even two different coins meet. These are the reasons we have no idea. And for that, we use what? This watershed algorithm. Now, this particular area are the borders. It can be obtained from the subtracting CO of FG area from CO BG area. CO BG area, we know that the background area, and then foreground area, we are subtracting bigger foreground area from the background area. So kind of noise removal we are doing using this one. You can see here kernel np1s tt np unt. So to know basically about a single function, whenever you are typing, you will get information about that function. It will display there. It will there will be a pop message. Pop-up message. Okay. So I hope you basically, if you have done some coding in Python, you are very much familiar with that. See, opening is done, then closing is done. Okay. Now, subtraction, we do it CB subtract, COR BC, COR FC. then the result here we got is this one. So in the thresholded image, we get some regions of coins which we have sure of coins and they are detached now. Detached means now it is being separated. In some cases, we may be interested in only foreground segmentation, not in separating the mutually touching object. In that case, we don't need to use the distance transformation, because suppose your means task is to only to find out the number of objects there, right? Then this is pretty much good. This is pretty much good because we are not interested in finding out that this is starting this one. So now we get the number. But in that case, also, we don't need to go for this distance transformation. Just erosion is sufficient. Erosion is just another method to extract some foreground area where you can see the result. Now we know for sure that which are the regions of the coins, which are the backgrounds and all. So we create a marker. Marker means what? Marker means of same size as that of the original image, but with integer 32 data type, and label the regions inside it. The regions we know for sure, whether foreground or background, are labeled with any positive integers, but the different integers and the area which we don't know for sure, we are just keeping it as 0. So for this, we are using CV connected components functions. It labels background of the image with 0 and other objects are labeled with integers starting from the 1, integer 1. Got it? Now, what happens that, but we know that background, if the background is marked with 0, Watershed will consider it as unknown area. So you know that now how the over segmentation occurs if marker is not used, right? Now Watershed is sure, Watershed algorithm is very much sure that if background is marked with 0, then it will be considered an unknown area. Now we want to mark it with different integers. Instead, we'll mark unknown region defined unknown with 0. That's how the labeling is done. See? We are using CV connected components, your foreground, add 1 to all levels so that your background is not 0, but 1. Then markers is equal to markers plus 1. That is what we are doing, right? Now, mark the region of unknown with 0. So markers unknown is now assigned the value 0. See the result. This is the ZAT color map result. Shown means shown in the ZAT color map. The dark blue region shows unknown region. CO coins are colored with different values. These are the CO coins. Different values are given. Now remaining area which are CO background are shown in lighter blue compared to the unknown region. So very much unknown region and some foreground region. So that's how the marking is done. See. Now our marker is ready. It is time for final step. So marker is done. The next step will be what? In that particular marker means labeled image, we will apply the Watershed algorithm. This marker image will be modified. The boundary region will be marked with -1. So markers CB Watershed image, comma markers. So image markers is equal to -1, assign this value to 5500. So now the result is ready. For some coins, the regions where they are segmented properly, and for some they are not. But still we are getting a better result. Got it? So this is the result. So now I hope that every concept is clear. So let's try to do this practically. I'm going to open Spider where I'm implementing this code using Python in means OpenCV. So you do the same. You can either go in for the cloud-based implementation, or if you have that particular means Anaconda installed in your system, you can go for Spider. Okay, let's start the coding. Okay, these are the just explained. I have already implemented it. So let's first clear the console. I cleared it. Then the result will be shown in this plot. Okay, first remove all the laser. Okay. Okay. So this is the codes. We'll execute one by one line. For that, in the last class, I have shown you what you have to do. Run the selection or current line. Import numpy np. Very much clear why we are doing this. If you are not clear about this, some of the codes, maybe I have explained in the last class. Please go to my last lecture, and I will keep the link in the last ending part of this video and in the means description section also. Very much important, right? Import cv2 as cv. cv2 is the current version of OpenCV. From matplotlib, import pyplot as plot. Then we are reading the image. We are displaying the image. Where the image can be seen? Here. See, this is the image. Actually, this image, now let me go to the next line. Okay. Gray version, gray version. This is the gray version. Okay. Then threshold that image. You have just seen the threshold. You can see now, this is the means output we are getting here. Let me, oh, okay. Now it is clear. Now, then go for the noise removal stage, opening and closing, shear background, opening, then distance transformation, right? Shear foreground. Okay, then we subtract the shear foreground from the background. Then we plot the image. This is the result we have got, right? Now this is the time for the marker labeling. For that, we are using the connected components function. See, better you take a screenshot of this and start typing by your own. That will be very good. Okay. And then marker done. Markers +1. You know why we are keeping the value 1. Add 1 to all levels so that your background is not 0, but 1. Then mark the region of unknown with 0. Unknown with 0. Those area which we are not sure of. Then now the time for applying Watershed algorithm to the markers result. We have applied it. Let's draw the image. We are plotting the image. And finally, we got the Watershed segmentation final result. So see how beautifully segmentation is done. Segmentation means here each coin is considered as different segment, right? So maybe some coins may be a little bit missed, but I think in this case, the better the segmentation result is far better because we are applying markers Watershed algorithm, right? If we not apply the marker portion, then the result will not be the same what we are getting it now. You can clearly see the result properly segmented. So these are the results. This is the original image and this is the final image, segmented image. Okay, guys, I hope I have explained everything. Still, if something missed, you can just ask me for comment. So this session will be continued. Whatever I find important that you have to know practically, I'll try to bring this in this series. Okay, that's all for today. Thank you.